Hello, 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 and welcome again to our next installment of organic chemistry with a focused look on our functional groups. So here you see on the screen a couple of items that we just need to make sure that we're aware of or that you have a moment to take any notes you may need, snap a picture with your phone, whatever the case may be. But these are going to be some of the items that you need in order to go forward with our second installment. So here you'll see uh, on your screen a chart that lists the prefixes necessary with organic chemistry, with the focus on naming your compounds. So if you see here, each corresponding number of carbons in your chain is going to be indicative of the prefix that you will use. You also will see here the chart used in this first installment where it discussed the name of the functional group, the skeletal structure, just so you have a visual representation. And then, especially for our first three, your equations or formulas you would use to determine that you have the correct number of carbon to hydrogen ratio in those three particular structures. Also down here at the bottom of that, we have all of the 8 functional groups we will be focusing on during our lessons on naming. So we have alcohol, which has an oxygen and hydrogen in its group. We have an aldehyde, which of course is a ketone, as you see that double bonded oxygen to a carbon, but we have a hiding hydrogen with that aldehyde. All right, two that are often mistaken for one another is amide and amine. Those two I want us to always remember when we see AMI, we are going to think of nitrogen. For whatever the reason, however you need to make that uh, kind of stick for you, I try to think of a minimum, AMIN. So we have a nitrogen is going to be the minimum that I need to look at. And then from there, I'm going to go further and see, much like when we're dealing with oxygen in our bonding and naming, we change the ending to IDE. You see here our nitrous functional group that contains a double bonded oxygen is named an amide. Okay, we move down to one of my favorites, the carboxylic acid. I remind people that it reminds me of a box car that belongs to a train, and trains go choo choo. So choo choo, we have a C, H, and two O's. So that's going to be the one functional group that we find that we could actually really spell some type of word with that. So we've got choo choo. We have our ketone here, which is a double bonded oxygen just to a central carbon with two rungs. And please be mindful that anywhere you see just a bond off of your particular element abbreviation, that is going to be a run. And quite often you'll see that noted in text or online with an R, a capital R. You might even see some apostrophes or what seems to be apostrophes. It's letting you know there may be more than one, maybe even 2 to 3 runs, depending on what that particular piece of literature is explaining. Then we have our two E's. We have ester and ether. I like to remind people ether is going to be a central oxygen. Central oxygen with a run on either side. So ether looks much like the word either, and we know that we're going to have a run on either side. We also have ester. Ester is going to have ether with a key. So ether with a ketone. If you notice that you have two oxygens, there are only two functional groups that we are working with at this time that contain more than one oxygen in the functional group. So if we see two oxygens, we need to make sure we look a little further. Is the oxygen bonded to a hydrogen, or does it just have another run off of it? And in the case of ester, it has a run off of that other side of the ether that is attached there. Okay, going down a little further, we also have need to make sure that we note any suffix changes that we will be using in the naming of our organic compounds. So each functional group, as you see here, you'll see the functional group alcohol appears as OH, a bonded OH in the compound, and the suffix is OL. So much like if we had uh, an alkane, alkene, alkyne, we would omit the E at the end of that word and replace it with the suffix for alcohol if that compound contains an alcohol. So we would replace that E with OL. Likewise with aldehyde, which is going to be COH, it's going to end with AL. So take a moment, take a picture of these, write them down, and I will suggest if you do take a photo, take the time to write this in your own handwriting. It has been proven that what you write, you are actually writing in your mind's eye. So I like to say you are placing it on the notebook of your brain. Much like you see in the picture before it, where it was your functional groups and names, use those index cards. $1 at the Dollar Tree, write those functional group names, write those structures, mix them up, throw them on the table, and match them. It's one of the best ways to actually practice those. You will notice with ether, there is an asterisk. You will notice that you have two runs off of your oxygen. So you'll have to name each of those runs. And in doing so, you'll have to place them in alphabetical order. And one thing you will note, they will be alkyl runs. So instead of having the normal ending of ane, een, or ein, you will actually replace the ending with YL. So you would use the appropriate prefix for the number of carbons, and your ending when you're naming a compound that contains ether will actually end in YL. Place those in alphabetical order, no matter what order they appear in the compound, and then place ether as the final part of naming that particular compound. It may not make sense now, but once we get down into working some of these out, I'm sure it will make a little bit more sense for you. All right, let's go ahead and take a look at some of the other notes we need to take at this time. So we need to make note of the first step being locate the longest carbon chain. So you're going to look at that compound. If you have to, draw the skeletal structure of the condensed formula you're given, and you may actually see what the functional groups are and where your hydrogens and things are bonded. So that is very helpful. You're going to name that parent chain using alkane, alkene, and alkyne naming rules, meaning we choose the appropriate prefix based on the number of carbons, and then we use the appropriate suffix, whether it has a single, double, or triple bond contained within that longest carbon chain. Once you have done that, you should be able to locate the anomaly or the functional group that is contained within your hydrocarbon. Once you do that, you can go ahead and change your ending of the compound to reflect the functional group that you found. So that's where we would go ahead, omit the E and replace it with our appropriate suffix from the chart above. Okay? So go ahead, take a moment, write those down. You can pause this, take a snapshot on your phone, whatever the case may be, and let's see what is contained at the bottom of this page. Oh, I'm sure you all say the dreaded let's practice. So let's see here. The first task that we are going to be doing is where and what is the functional group. So when looking at our condensed formulas, we should be able to find the anomaly or the thing that is different from our normal plain hydrocarbons. And we know that plain hydrocarbons by the name contain only hydrogen and carbon. So we're going to be looking for the items that are different. So I'm going to change the view on my screen here. Give me just a moment. All right. So let's go ahead and give this a try. We're going to look here at our first compound, and according to our rules, we're going to locate our carbon chains. So here I see a carbon surrounded by hydrogens all on this side here. It's bonded to a carbon. We have another carbon. Oh, what do we see here? I see a carbon that is not bonded to a hydrogen. So this here kind of makes me suspicious. Then I go, once I find something that looks different, I need to look to the left and to the right of it. So here to the left of my oxygen that I have located is a carbon. So more than likely that oxygen is bonded to this carbon. But let's see what's happening here. It is now going once again into another set of what we are accustomed to seeing in our hydrocarbons. So I see a carbon bonded to two hydrogens, which is then again bonded to another carbon that is saturated with three hydrogens. So here I would say this is going to be my anomaly. This is going to be what I need to focus on naming. So if I look back at my chart, I know that something that is going to be bonded, we've got an oxygen bonded here to a carbon. And I think if we go ahead, highlight that, let's go ahead and see what we have. And according to that chart, we are going to have a ketone. I hope that you can see here, much like the picture, we have all of our carbons are bonded together, and then we're going to have this oxygen off to the top of it here, maybe even down here, depending on how that visual representation is drawn. So let's take a look at our next problem. Here we're going to have some items where we go all the way through and we look at our chain and we know that we have carbon and carbon, but then after we get all the way to the end, I run into a nitrogen. So I already know that there's only going to be two choices because there's only amide and amine that actually contain nitrogen in the 8 functional groups that we're studying. I do not see an oxygen, so this is going to point me in the direction of this being an amine because all we have is nitrogen with 2 runs or just two hydrogens off to the side. Okay, so let's take a look at our next one. Once again, we're going to go through looking for our carbon chain. It looks like I have a really long carbon chain, but I get to the end and we have an oxygen and a hydrogen. And I see that to the left of it, I have a saturated carbon because he's attached to his hydrogen, and then he's attached to the previous carbon. But here we have OH. And one of the only ones that we have, and the one that I really love to make sure that everyone understands, is alcohol. A lot of times the example I use is when someone goes after they turn 21, it's their first time being able to go, and they are oh so excited for the opportunity to go. So they are screaming, oh! So there we have alcohol. So let's take a look at our next one. Here we have a series of carbons attached to their hydrogens. And once again, we get to the end and we see, oh my goodness, that looks to be a little bit different than anything else I've seen. So I look to the left of this hydrogen and I see I have it bonded with a carbon. And then I look here, I have this oxygen, because typically, if we look at all of our hydrogens, they have some type of subscript, some type of small number. So when I see hydrogen just sitting there by itself, it makes me stop and wonder, what is this that I'm looking at? What about this makes me think I need to look deeper into what I am being asked? So let's see, what functional group do I have that contain all three of those items? And we must remember, if we're using the uh, suggestion of drawing these skeletal structures, we have to remember that carbon is tetravalent, okay? It is going to have the ability to have 4 bonds. So if I draw the beginning of this carbon or parent chain of carbons, it's going to have a single bond to the carbon ahead of it. We know that it's going to bond to that hydrogen with 1 bond, and then that leaves my oxygen needing to bond, because we know hydrogen only has the ability to have 1 more spot to bond, and it bonded to that carbon right here. So here we know carbon has used up 1 bond here with a hydrogen and a bond with the carbon ahead of it. So it has 2 left here for this oxygen. So if that's the case, that means I have a double bonded oxygen to this carbon with a hydrogen hiding, behind that. So there we have an aldehyde. Okay? So let's take a look here at our next structure or our next formula. We're going through, we see our carbon and hydrogens that are saturated. They're saturated. Once again, I'm coming to those single hydrogens, but I look here and I go back to a carbon. So that lets me know that there's a different bond here than what I've had in all of my previous problems with these type of examples. So I know that this here is not necessarily going to be a different type of functional group, just a different type of bond. So this here being just CH to CH would let me know that there is a different type of bond happening here. So that would let me know I need to look for it to possibly be an alkene or an alkyne. but we're not working on that type of identification at this time. That would come once you have drawn your uh, skeletal structure and kind of see where that is. But let's go a little further and see if we can locate any actual functional, any of the 8 functional groups we were working with. So here we keep going. We see CH2, CH2. I've gotten to a carbon and 2 oxygens and a hydrogen. And I know that oxygen is going to be an anomaly. It is something different than what I normally see. So this here is going to be the functional group that we will actually be trying to name. And if we think about the groups that we were looking at, we stated that there are only 2 functional groups that we are working with that contain 2 oxygens. That would be our ester, who has an ether and a ketone. And that's not what we have here because there's a hydrogen. So there's only one other item that we name that actually has 2 oxygens, a hydrogen, and a carbon. And that's going to be our choo-choo train or our carboxylic acid. There is our C, our O, which would be double bonded, and then we have our oxygen and hydrogen bond off of that ketone. So let's go ahead and take a look at the topic that this is going to be or is going to be added to the ability of doing your functional groups. So here you're going to see CH4. If we recall moments ago, I stated that carbon is tetravalent. It has the ability to bond or have 4 bonds. So this is just going to be using the appropriate alkane, alkene, or alkyne because all we have are hydrogens and carbons. So we are naming a hydrocarbon. So the first thing we do is count the number of carbons and choose the appropriate prefix. So here in CH4, we have only 1 carbon, which we see here. And then we know, according to our prefix chart, that 1 carbon, the prefix for that is meth. So if we have a saturated carbon, that means that every bond carbon could have would be filled with a hydrogen in this case. So we have a saturated hydrocarbon, which means we have just 1 carbon and full of single bonds. We have meth, which is going to be the associated prefix. And then the ending is going to be ane because we have nothing but single bonds contained within that compound. Okay, and the formula for alkanes is here. N is your number of carbons. Then for your number of hydrogens, it would be 2 times your number of carbons. So in this case, 2 times 1 is 2, plus 2 gives us 4. So we have CH4, which is exactly what we have here in the beginning of our problem. So let's take a look at the next one. Let's name this one. First, we need to locate our carbon chain right here because we have a very linear representation of the formula. We have 1, 2, 3 carbons. We need to choose the appropriate prefix that is associated with 3 carbons. Also, if we take a look, every bond that these carbons can make, it is filled with a hydrogen. There are no uh, anomalies like oxygens or nitrogens in this process. We know that we're going to be dealing with an alkane. So that would be our suffix at the prefix for three is prop. Prop is the appropriate suffix or prefix, excuse me, for three carbons. So let's take this and go a little bit deeper and actually name something that contains one of our new functional groups. So step one, we are going to locate, okay, we are going to locate our number of carbons we have, and we are going to count. So we have 1, 2, 4, and 5. So I know that I'm going to be dealing with bute according to my chart for the number of carbons. So here, that's going to be the basis of our name. So we're first beginning with bute. Also, we have our functional group here. So we know that that is going to be our anomaly this time. Okay? So in our naming, bute, and our representation. But we have an alcohol bonded to that butane. So if we go back and look at our rules, we know that we must first omit the E and add the appropriate suffix. So we know bute, we know ane, because those are the type of bonds that we have, and then our suffix for alcohol, which comes directly from our chart, are the letters O and L. So here we would have butanol. Butanol. There is our bute. So let's change these colors just a bit. Alcohol will turn. So here we have bute. That is going to be associated with our number of carbons. Okay. Our bond, since we had all single bonds, those things come into play. So there we have our alkane, because we know it's full of single bonds. So let's go ahead and turn. Okay. That's where this came from. But we know that according to our rules, if there is a functional group, there will be an appropriate ending to use once we omit the letter E at the end. And in this case, our ending is going to be OL. So this is where the entire name butanol comes from. We have our number of carbons, the bonds that us or so let's take a look at our next problem. Here we look up, we've gotten to another carbon, but to the right of him are some anomalies. I see oxygen, but then again, I need to look again. What else is also attached to this. I have another oxygen. So now I've already narrowed my choices down to the only two functional groups that I could possibly use that have two oxygens. But what else is there, if anything? And for this particular problem, there is a hydrogen. So if we see here, our anomaly is COOH. COOH. N is my functional group. And we know, according to our chart, those that contain two oxygens, a carbon, and a hydrogen is going to be our carboxylic acid or our choo-choo train. Okay? The number of carbons that are contained in this structure. And do not forget, we also have to utilize that carbon there as well. So we will also be counting him, but he is still part of the functional group. So get that, okay? Here we have all single bonds again. If you notice, CH plus CH2. So that carbon has all the hydrogens he can have because he's attached to another carbon. Here again, we have another carbon. So we have 1, 2, 4, 5 carbons. So according to our chart, 5 would be pent, okay? Nothing but single bonds gives us anes or alkanes. So we can go ahead and know that we would be dealing with a pentane, but we must omit the E and add the appropriate suffix. So let's go ahead and do that now. Here you see pentanoic. So there is our pent for our number of carbons. The AN, of course, this A notates that we are dealing with the alkanes. Okay, so once again, we are doing uh, uh, and then OIC acid is the appropriate ending for our carboxylic acid containing functional groups or compounds, I should say. So here we have pentanoic acid. Okay. Now our final example today, we're going to begin locating our carbon chain. If it contains our single, double, or triple bond, and what functional group it contains. So here I see carbon, and uh-oh, I already found something that is different. And here I have an oxygen. Well, what is attached to the right of that? It's another carbon. Is that carbon by itself with the oxygen? No, it is not. It goes once again into a normal carbon chain. So here I have an oxygen that is all by its lonesome, which lets me know that that is going to be my anomaly. That is my functional group. What functional group do we have that only contains oxygen? Not only does it only contain oxygen, it has a run on either side. So here we have a carbon chain with only one carbon. So we're going to have to name him. Then we also have to the right of that functional group another set of carbon chains or carbon runs. So we'll have to name this one as well. And if we recall the rules on naming our hydrocarbon chains that contain an ether, we know that we first are going to locate the number of carbons. We are going to then, instead of having "-ane", "-ene", or "-ine" as our suffix to our prefix for the number of carbons, these are now considered alkyl groups and will actually end with YL. Now, the only other caveat to this, or the only other special case, is that when you're dealing with ethers, you're going to put your hydrocarbon chains or runs in alphabetical order, no matter how they appear in your structure. So if your first one just so happens to be uh, a hexyl, HEXYL chain, and then you have an ethyl chain, your ethyl chain will come first, even though it appeared second in your representation. And that will make sense when you take a look at our answer for our ether here. Here we have butyl. Well, if you notice, butyl has to do with a certain number of carbons. That would have to associate with these last here. These last four would be considered your butyl run. Even though it is second in your representation here, it will actually appear first because in alphabetical order, B comes before M. And the methyl group here is associated with your first carbon in this run, our own special. So we'll make the methyl chain purple highlighted color. Go ahead and add our ending that lets us know we are dealing with a compound that contains an ether, and that run has now been taken care of. We have our carbon chains named as their alkyl runs, and then we have them in alphabetical order, and they are placed in order based on their alphabetical placement. So butyl, methyl, ether. Now, a couple of other things I want to make sure that you have done is that you have made sure to understand the four that longest carbon chain. Name that parent chain using the appropriate alkane, alkene, and alkyne naming rules. So choose your prefix based on your number of carbons and your suffix based on the type of bond contained within your compound. Once you've done that, locate the functional group. Look for the item that's out of place. Everything up until now has always been hydrogens and carbons. If you see anything other than hydrogen and carbon, that flag should raise up, and that's where you should begin to look to the left and to the right and see what functional group has been represented. Once you've done that, omit the E and choose the appropriate suffix. I hope this was helpful and have a wonderful time studying. Happy studying to you.